Welcome to my CSA final project. This is a calligraphy calendar, which is meant to help me practice calligraphy every day, while it also helps me memorize vocab words from my favorite book, Blood Meridian by Cormac McCarthy. This is my original AI code running. Initially, you would have to select your script, or the code would automatically randomize which script to practice for that day. And then you could input notes about how the session went. Then you had to click save, then OK, and that would also be the color you needed to practice in through that day. However, this was a little clunky because if you didn't hit save and OK, it would just close the window and it would not save. Another function of this program was that you could go back or forth in time to see what the word for that day was, or to log practice for previous dates. Looking at the overall structure of the code, these are the variables which form the code, which match the UML diagram's first quarter. Draw calendar is what actually generates the monthly calendar view based off of the month and years you select, and it creates the grid of buttons which represent each day and shows all the saved data, like the color for that day mainly. That matches this part of the UML diagram. Open practice pop-up is what actually creates the pop-up window for each day, and it allows you to update the data like the word, script, color, and notes. That matches this part of the UML diagram. The generate random day data generates the randomized parts of each day data entry, including the practice word, script, and color. And that helps run in the background to make the data for each day. The static class of day data allows each day to have its own set of variables, being the date, word, script, color name, color, and notes for that day, without requiring an instance from the calligraphy calendar for each day. So that's why it's a static class. That ties into the next part, where among the three concepts I chose to research were static classes, set default close operation, and invoke later. Static classes can be thought of inheriting the variables and methods of the outer class, which would be calligraphy calendar in this case, but they don't need their own object, calligraphy calendar objects, to be created. So it just inherits the larger class, but also has logical coherence. In this example, the static class is nested in an outer class, but you don't need an object from the outer class to create an instance from the static class. This would be impossible for a non-static nested class, which would need an instance of the outer class to create the inner class's object. And this is in action. You can see that the program's function is executed here, and it didn't need an object from the static class example class. Also, that would mean in the context of my calligraphy calendar code, if the day data class were not static, each day data object, so each day and its pop-up, would need its own reference to a calligraphy calendar object, which is less efficient. Next, invoke later, it helps to make sure that threads of code are executed in order to have a desired result. The next topic I researched was invoke later. To understand invoke later, it's useful to understand threads, which are specific paths of code that the program executes in order to have a desired result. The specific thread that deals with most graphical user interfaces, or GUIs, is the EDT, which is the event dispatch thread. This determines what happens with the visuals when clicks and other things like typing happens. However, the user interface may only be updated from the EDT path, or else bugs or crashes may occur, like if the updates were happening from the main thread instead. As such, invoke later on a line of code makes the code's effect come later, but with the EDT path as soon as possible, without interfering with the current thread's execution. So it's just saying like save it for later, and it orders the paths to be executed on EDT. In this example, you can see that a window pops up, which is the invoke later demo. With that in mind, it's usually visually hard to show invoke later because unless you're seeing the error, it won't actually show up visually whether you use invoke later or not. However, this code shows that the main method finishes first, and then the frame creation happens, making it visible, and that's run on EDT, not the main thread. And if it were run on the main thread, main method, it could cause a crash. In the context of my program and large Java Swing programs in general, it just means that invoke later allows for no crashes nor bugs, and also it allows organization of the code as a whole. The third concept I wanted to go over was set default close operation. So this method actually has parameters in the forms of ints, and they determine what happens when the X is closed on a window, like here. When the parameter is 3, it terminates the program as well when the window is closed, so it deletes everything. When the int parameter is 2, it just deletes the window and frees the resources, but the application continues to run. When the int parameter is 1, it only hides the window, and 0 makes the JFrame actually ignore the pressing of the X, which could be for like a do you want to save option, for example. However, this method, when it takes ints, doesn't actually require the raw int constants, raw int numbers, but actually it has int constants which are defined in window constants interface, which the JFrame automatically implements. So that's why you don't see the raw numbers here. For example, this would be an example of int3 as the parameter, as it closes the program and the code. This would be an example of the int2 parameter, where it just disposes the window on the close, but the app continues to run. This would be an example of int parameter 1, where it just hides the window. And this would be an example of the int parameter 0, where pressing the X doesn't do anything, so I made this button to close the window for me. In the original code, this concept shows up on line 41, where when the entire window of my calligraphy calendar is closed, when the X is hit, it stops the program and causes the window to disappear. So the changes I wanted to implement were for aesthetics, more colors, and for functionality, no more needing of the OK button, so you could just click save and the day data window would close, and a find today button option. To get rid of the OK button and only have a save button, I had to work with show option dialog. This always comes with an OK button, but technically it has up to 8 parameters. The 6th parameter deals with the custom icons, the 7th parameter deals with custom buttons, and the 8th parameter deals with the pre-selected button. However, this method always has an OK button, but that can be changed, and that's if you set 6 to null, that means that there's no more custom icon. If you set the 7th to an empty array, that means that there's no default OK button, and setting the 8th to null also means that there's no more OK button. So now that the save button has to do the closing of the day pop-up, as well as saving the data. The implementation of a custom save button was too difficult for me, so I had ChatGPT do it, because I didn't know that Swing programs had a function for creating a custom save button. And to implement this, you would need to have a window ancestor, which this finds the window that an object is on. In this case, the save button is on a J option pane, which is the pop-up, so it knows to close it through the if statement, which is the if it does not equal null, dispose when the save button part is clicked, as well as saving all the data through this way. The next part was far easier, which was just adding more colors, so that means more aesthetics, and to each color that I added to this final list, I would have to match with a color from here, which could be preset, or you could determine the RGB values for it. I added pink, cyan, yellow, and orange. Another functionality feature that I thought I could update and add was making a today button. So this little portion makes a today button, and the add action listener means that when that button is clicked, it executes this portion of code. Java actually has a time API which allows the program to know what time it is based off of the Java servers, and based off of that, it would set the drop down month box equal to the month index because the J-frames use indices, and the year box to the year. And then it would remake the month with a draw calendar method which was already determined beforehand. And ultimately, this is the code running with modifications, where I could select any date, anytime, go. I could put in my notes, and there's no OK button that I have to go through. I'll click save, that's brown. This will be cyan, brown again. So there are the more colors coming in. And I have a today button, which also works. And that is my AP CSA final project. Thank you for a wonderful year, Mr. Lamson.